Good morning and good day, everyone. My name is Tony. I am a course advisor at EIT and I will be your host for the day. And thanks everyone for taking their time to join today's session. Before we begin, I'd like to cover some few notes so that everyone get the most of the session. On your screen now, these are the notification and sound options. You are able to switch on and off the notification and sound as you wish during the session. Please post any questions under the Q&A function at the top right hand corner. If the questions are technical, our presenter for the day will be able to assist regarding that. But if it's a more general questions to EIT's course offering, I will be able to assist that on the chat box. Today's topic is going to be exploring EIT's mechanical engineering options, and our presenters for the day will be Dr. Arti, Dr. Arvin, Dr. Milind, and our student Nozibusiso Nkomo. Okay, so these are some of the frequently asked questions. So everyone registered for this webinar will receive a copy of the PDF slide and a link to a video within the next 2 business days via email. So please do check your junk folder, spam folder if the email does not appear in your inbox. We will also provide you with a free digital certificate of attendance for live attendees. There will be a link and a QR code to a short survey provided at the end of the session. So do stay with us until the end of the session to qualify for the certificate of attendance. Okay, so this is the agenda for the day. I will be handing it over to Dr. Arti to introduce herself. Following that, Dr. Arvin will do the same. So is Dr. Milind. Dr. Arti, you can take control of the slides.
Thank you. Thank you very much, Tony. Hello, good morning, good afternoon, good evening, everyone. Thank you for being here. My name is Dr. Arti Siddhpura, and I'm course coordinator, research coordinator, and senior lecturer based at Perth campus of EIT. I've been in academia for quite some time now, and I have my background in mechanical engineering. So I look after Bachelor of Mechanical Engineering course as well as research units with EIT. And as you can see, my research interest align with my mechanical engineering field as well. So condition monitoring and diagnosis, prognosis of tool life, those are some of my research interests. Thank you. Over to you, Dr. Aravin.
All right, thanks, Dr. Arti. Hello, everyone. My name is Arvin Arumugam. I am also a lecturer at EIT in the Mechanical Engineering School of Mechanical Engineering. Apart from being involved in the higher education teaching, I'm also the program leader for the advanced diploma, a few number of advanced diploma courses. Thank you.
Thank you, Dr. Arvin, and hello everyone. I am Milind. I'm one of the course coordinator and a senior lecturer at EIT, and have a few years of experience in academia and the industry. So I did my PhD in mechanical and published quite a few papers, and I'm currently with EIT developing and delivering bachelor's, master's, and doctorate programs in mechanical engineering. So welcome all.
Thank you so much, Dr. Arvin and Dr. Milind. All right, so I will take over back and I will start with brief overview of mechanical engineering, and then Dr. Arvin will present about job opportunities and the upcoming trends about mechanical engineering. And lastly, Dr. Milind will talk about the courses that we present here at EIT, and then we will finish off with our student experience as well. So let's move on and start with what is mechanical engineering. So Mechanical engineering at its heart, it's all about designing, analyzing, and manufacturing systems that involve motion and forces. Now, the mechanical engineering, the entire field is grounded in physics, mathematics, and material science, and it powers much of the technology that we use every day on our day-to-day basis in our day-to-day life. Say from cars we drive to the coffee machines that we use. Mechanical engineers are always there behind the scenes, making sure these systems are efficient, they are safe, and they are reliable. Now here on this slide, you can see the key knowledge area. So when someone says that I have studied mechanical engineering, majority of those areas will be covered by their course. Let's dig a little bit deeper into those areas. So these are various different branches. Mechanical engineering field branches out in so many different areas. And here I'm giving you a brief idea about where exactly it branches out. So we will go into each of them one by one. The first one is computer-aided design or CAD. So as we know, engineers use CAD software to create precise models, blueprints, and that also helps them visualize and test the products that they want to build. So basically, before any prototyping happens, all the design, simulation, analysis, and testing happens using the CAD software. Second field where mechanical engineering branches out is manufacturing engineering. So manufacturing engineering, as the name suggests, it focuses on turning any raw materials into final finished products. And mechanical engineers ensure that those things they happen quite efficiently. They also think about how the assembly line will work, how the automation can be embedded, and nowadays, more importantly, they also think about sustainable design, product lifecycle management, cradle to grave design intent. So that's there. Continuing with that, so the next field we have is automobile engineering. And as the name suggests, as all of us know, automobile engineering is safer, more efficient, and environmentally friendly. Nowadays, we are looking at a lot of electric vehicles, hybrid vehicles. This is the demand of the time. And again, we have United Nations Sustainable Development Goals to achieve. So engineers also look into that field. All right, next really important one would be air conditioning, or sometimes we also refer to it as HVAC. So HVAC engineers usually work designing systems that control temperatures and air quality in the buildings as well as industrial spaces. They ensure that there are comfortable temperatures. If it's geographically very cold area, they will also ensure that there is a warm temperature inside those buildings. If it's a very hot area, and cold, enjoyable temperature in that part of the world. Moving on, next we have materials engineering. So materials engineering, as I say, it's one of the core or root of the mechanical engineering. Materials and mechanical engineers, they go hand in hand. So mechanical engineers are most of the times also choosing the right materials. They want to have the right and the most efficient material. It could be a metal, it could be a composite. They want to choose the right material that can give the sufficient strength that they need, the durability of the product, and they also want the right performance from that material. On top of that, they also want to ensure that material is locally available, and while getting that material doesn't leave a lot of carbon footprint. The next area we have is power plant engineering. Plant engineering, some of you might argue that power and electricity is more of electrical engineering, but I would say that at the back end, it's a lot of mechanical engineering. So power plant engineers, they design systems that generate energy, and it could be using anything. It could be fossil fuels, or it could be any renewable energies like wind or solar. But again, the back end of any engineering into them. Next we have is mechatronics and robotics engineering. So here they are combining mechanics, electronics, and computing to build smart machines. It could be the robotic vacuum cleaner, people in their day-to-day life, or another industry operation. So these are the robotic engineering. Next we have is agricultural engineering. So agricultural engineering about improving farming equipment and mining systems. They also make sure that all those things are done in most environmentally friendly way. Next we have is mining engineering. So as I mentioned, mining processes also mechanical engineers start to make them as efficient as possible. And again, whatever environmental impacts, they would try to reduce them as much as possible. We then have oil and gas, and I'll just go through a couple more slides. We have marine engineering and we have aerospace engineering as well. So those fields in ships, submarines, aircrafts, or spacecrafts, and always back of the mind, they are very common for any mechanical engineering working in any branch of mechanical, that they want to make all those systems quite efficient, and they also want to make them quite sustainable, or in other words, environmentally friendly. So these are various different branch of the mechanical engineering. Mechanical engineering, as we can see, they are everywhere. Let's say it's from the ground beneath us to the skies above us. It's a field that drives innovation, solves real world problems, and mechanical engineers also shape the future. So, yep, that's about various different branches of mechanical engineering. Thank you for your time, and I will hand it over to Dr. Aravin. Dr. Aravin, please feel free to take control.
All right, I'll take control. Thank you, Dr. Arti. All right. Fine. Let's now look into a few of the potential job areas that we might have in mechanical engineering. Obviously, Dr. Arti have actually gone through on the various different types of mechanical engineering branches that we have got. So what I'm going to do in the next probably about 10-15 minutes is just to go through some of the important recent trends in mechanical engineering. As you can see in that list there, as a mechanical engineer, you can potentially work in a wide range of branches, going from computer design all the way to oil and gas and marine engineering and stuff like that. So mechanical engineers, even though you've got a mechanical engineering degree, you might end up working on a diverse range of mechanical related branches, right? And what I'm going to look into quickly today is some of the important branches, some of the expert related branches that you have in mechanical engineering, and hopefully that will give you a bit of idea what you might come across when you are joining our bachelor's or master's of mechanical engineering, right? Now, probably just to bring up another important thing is in here is, as you can see, this is the recent Australian government's statistic on shortage on engineers, especially what we have got here is the mechanical engineers. In fact, even yesterday, someone shared that Engineers Australia is actually requesting for number of graduates to be increased to about 60,000 here in Australia, right? Because we got a range of shortage in mechanical engineers. And I think the thing in here is the shortage in here is not because we don't have mechanical engineers. We do have mechanical engineers, but we might not have people with the required skill that follows the current trend, the trend that I'm going to talk to you about in a bit, right? So that's generally what it is. So saying that, let's go into the first one. The very obvious, very common, I would say, area that a lot of people talk about, that is the 3D metal printing, right? So when we talk about 3D metal printing, where is this particular area of metal printing comes in? Generally, we can look into metal 3D printing is widely used in manufacturing, especially to manufacture load-carrying components. And we use this quite a lot in industries like aerospace and constructions, automotives, and so on, because 3D printing is able to create very complex lightweight designs with very excellent strength properties. I think we've got a number of what they call this additive manufacturing or 3D printing techniques, but probably two of the common that we have when it comes to metal 3D printing is the selective laser melting, SLM we call it, as well as the direct metal laser printing, DMLS, right? So generally, as you can see in that figure in here, we've got a a 3D model or a CAD model. We send it into this 3D printer, and you'll have a laser that scans and selectively fuse and melts the metal powder and slowly build a part layer by layer. Now, that's generally what 3D printing is all about. Now, the global metal 3D printing market is actually increasing quite drastically, right? It's kind of looking into about USD 9.66 billion in 2024. This year is actually increased by about USD 12 billion in 2025. And it's estimated that it'll increase to about 87.3 billion in 2034. So you can see that this metal 3D printing market is growing rapidly. And one of the typical reason is some of the main industries like aerospace and automotive are generally looking into rapid prototyping to test their design, right? So when it comes to design, we need prototypes. And 3D metal printing is allowing you to rapid prototype metal components for the sake of testing and analysis and so on. So generally, that's where metal 3D printing is coming quite handy and quite successful, I would say. Now, along with that, we've got something called the 4D printing. Now, how different is the 4D printing compared to the 3D printing is simply 3D printing is very much static in nature, but 4D printing, you just add another dimension. It allows objects to be created using smart materials that would be able to change function, okay, whenever there is an external stimuli. For example, a change in temperature, a change in light, moisture, and so on and so forth, right? So we do have 3D printed components, but they are static. This 4D printed components, they literally, the last D is literally the last dimension is actually time, right? And we use this quite a lot. For example, in aerospace, in satellites, right? Where nowadays you're constructing all these self-assembling and self-repair type of components in, for example, for satellites. In healthcare, we've got all these implants that would be able to change shape, function, and so on based on the need of the body. So 4D printing is obviously another area mechanical engineers are working on, right? And a very evolving branch, I would say. Now, computational fluid dynamics. This is another interesting area where mechanical engineers will be involved. You see, generally mechanical engineers, we are involved in a lot of design of machine components, okay? Machine components that are involved in conversion of energy and so on. So literally, when you talk about design, the aspect of testing the design comes in hand is important. And that is where we look into prototype. Well, we do have physical prototypes where we can do testings and stuff like that. That's probably one of the main reasons why we have got 3D printers came out. 3D printers, as I just mentioned, is meant for rapid prototyping. But obviously, with the advancement of computer power, right, we can even do computer simulations nowadays. And CFD, computational fluid dynamics, literally uses this vast, complicated numerical analysis, algorithms, and stuff like that in order to simulate and predict the flow of fluid as well as heat, right? We do use this a lot in a lot of industries, like, for example, aerospace, right? In aerospace, in order to predict the airflow of around aircraft so that we can calculate the lift and the drag and so on. CFD is widely used. We use CFD even in automotive. So for example, if you are designing a sports car, how should the chassis be? How should be the structure be? Or in order to reduce the, or in fact, to improve the fuel efficiency, right? And as you can see in one of the pictures that we have got, how we can actually simulate intricate fluid flow. For example, the flow of blood in surrounding or across, going through the heart and so on. Now, all of this is quite intricate, and we may not be able to have a prototype on it. So simulations like this comes handy. And engineers will obviously be involved in a lot of this kind of analysis. Well, the other important thing is the electrical vehicles. Now, mechanical engineers traditionally have been involved with the design and manufacturing of cars, right? But the cars that we were looking into in the previous days, I mean, kind of in the olden days kind of a thing, is those with the IC engines, internal combustion engines. Now we have got the electrical vehicles. So do we mechanical engineers still involved with electrical vehicles? Yes, we are. Mechanical engineers are literally involved in areas that kind of focus into the design of the vehicle body, the chassis, the suspensions, the brakes. Not only that, it also looks into the integration of the battery with the chassis, right, with the structure, the thermal management. So literally, when it comes to electrical vehicle, mechanical engineers are still involved in designing the chassis that meant to be rigid, comfortable, as well as able to place a heavy battery in it. We are also looking into the powertrain integration with the electrical motor. Okay, obviously the battery will actually release heat. So how do you manage the heat that's coming out? Now, all of these are part of the job of a mechanical engineer. All right, the other two that I'm going to talk about, the nanotechnology and the biomechatronics, the one on the next slide. Right, these are two very interesting areas where mechanical engineers would potentially, or in fact, not potentially, are obviously involved. Right, nanotechnology engineering typically involves designing, creating, and manipulating. I think that's the word, manipulating materials at a very atomic and molecular level. That kind of goes about, say, about 1 to about 100 nanometers and so on. Now, what actually happening in here is in nanotechnology, we are actually we're taking a material and we are going to the nanoscale of the material so that we can, in fact, disturb or manipulate the arrangement of atoms and molecules. And with this, engineers are able to create new materials, stronger materials, efficient materials. For example, the lightweight composites and the advanced electronic components that we are using and so on. Now, all of these are part of nanotechnology. Right. One of the common ones that we talk about is in manufacturing is the use of nanotechnology for this micro nano electromechanical system. We call that the MEMS. I don't know whether anyone would have heard the term. We call it MEMS. Similarly, typically to design sensors and actuators that are very nanoscale in nature. Right. So that's the thing. The next one that we are looking into is biomechatronics. Now, biomechatronics generally comes from mechatronics. Now, if you look into mechatronics itself, mechatronics is an interdisciplinary, multidisciplinary field of study that covers mechanical, electronics, computer science, what else, control systems, right? Now, all of this. So typically to develop intelligent systems, that's mechatronics. But the moment you incorporate that with human biology, right, or with human physiology, then we've got biomechatronics. And mechanical engineers are obviously involved on this kind of biomechatronics because we design advanced prosthetics for prosthetic limbs and so on. We design all these assistive technologies for rehabilitation and to improve movements for people with disabilities. And for example, recently medical robots are coming quite famous, where we are able to look into surgical robots that are able to do medical procedures. Now, all of this comes under biomechatronics, and you obviously will see a mechanical engineer being involved in that, right? Well, the next one is a term that we all would have known, Industry 4.0. Now, Industry 4.0 typically looks into the intelligent networking of machines and processes. Okay, machines and processes for any sort of industries in order to kind of help with any sort of flow or the flow of information and communication, right? That's generally what Industry 4.0 is. In this Industry 4.0, we've got these 5 main branches that we are, everyone's looking into, right? IoT, the Internet of Things. I'll mention that a bit briefly in a bit. Artificial intelligence, robotics, cloud computing, as well as real-time analytics. Now, when you combine all of these together, you've got Industry 4.0. Industry 4.0 is the 4th industrial revolution, right? We have actually in the 4th industrial revolution. In fact, we are in the 5th industrial revolution, coming into that. Anyway, finishing what I was just going to say, right? So by combining all of these 5, you're able to create a more holistic, a more connected ecosystem for companies to be able to focus in their manufacturing, supply chain management, and all that kind of things, right? Now, as I was just saying, we have already passed Industry 4.4. We are going into Industry 5.0, right? Where we are building up from Industry 4.4 in terms of automation and efficiency, and we're adding another additional layer to it. That's the human-centric innovation, to make sure that humans are able to work together with automation, robots, and so on, and also to make sure that the system is more personalized, sustainable, and that kind of thing. So Industry 5.0 is what we should be talking about at this point in time. And Industry 4.0, 5.0 might not even work without the Internet of Things. But Internet of Things is more, at times can be referred to more on surface oriented. But if it's relating to industry, we call this industrial Internet of Things. IIoT is the backbone of the industrial revolution, right? It literally looks into a collection of sensors, instruments, any sort of autonomous devices, everything connected together through internets, okay, for the sake of any sort of industrial application, processes, and so on, right? That's IIoT for you. All right, another interesting area that everyone's looking into in mechanical engineering, the digital twin, right? Now, the digital twin is typically a digital replica of a physical object. It can even be human. It can even be human, a system, any sort of even a process that can be existing in a digital version of its environment. So we use digital twin a lot nowadays to find, in fact, a lot of organizations are using in digital twin to simulate real life situations, to simulate real life processes, and try to see how what might be an outcome that's coming up from that. And with that, with digital twin, ultimately we are able to do a lot of good decisions, meaningful decisions, decisions that are cost effective, and so on. Right. So that's digital twin. It's generally, we create a CAD model. That CAD model is kind of like, in a way, connected to a Internet of Things. So the sensors that are attached to the IoT provides data to the CAD model, and the CAD model is able to simulate to whatever information that's given. So that is digital twin. Right, just to finish off this, the last two probably are more of a software base. So we have got something called the product data management, PDM. Now this looks into a bit more on, it's a software that looks into a system management of design data and engineering processes. So when it comes to design, manufacturing, and all kinds of things, we need to have a very centralized location for all the information relating to design manufacturing can be in a way stored, so that anyone, it could be an engineer, it could be a manufacturer, whoever, will be able to go in there and look into the, for example, the bill of materials, the design related information, or any sort of track revision changes. So this kind of information, if you want to put that into a more centralized location in a software form, we do have something called the product data management. But together with that, we've also have got another software that looks into the life cycle management of any product, PLM, right? That is pretty much a tool that manufacturers, designers use to manage the product's data, starting from inception all the way to the point of disposal. So that's why we call this the lifetime management of any product, right? Okay, everyone. So with that, I just want to finish off what I was just saying. So the field of mechanical engineering is quite diverse. There's a lot of things as a mechanical engineer you can learn, you can contribute to the community, right? As you can see, even in the screen there, we got a lot of different things that's happening, right? So as a mechanical engineer, I think you will be, in a way, especially at this point in time, will be contributing quite a lot to the up-to-date advancement in science and technology. All right, with that, I'll just finish off my my presentation. Thank you. So I'll just pass this to Dr. Milind now. Thank you.
Thank you, Dr. Arvin. It was really good. And thank you, Dr. Arti, as well. So yes, hello everyone. I'm Milind here again, and I'm going to talk about mechanical engineering courses. So what courses are we going to have? Just need to take my control of the slides. Can you see this mechanical engineering courses slide? No?
You have not taken
Changing.
control yet, I think.
Okay. Okay. Yeah, yeah. Now it should be okay. Yeah. So I'm going to talk about mechanical engineering courses, everyone. I hope you can see it now. And in the courses, you can see EIT programs are actually having variety of courses starting from, uh, you know, sorry, the view is changing on my side. Just a minute. Yeah, so here you can see, we offer 3 months professional certificate of competency, for example. It's a shorter course, and then we have diploma, which is only in leadership and management, advanced diploma, undergraduate certificate, bachelor of science, graduate certificate, graduate diploma. Then we also offer full master of engineering and also a doctor of engineering course. So let's talk about each one of them. So starting with professional certificate courses, in case if you think you might be in a different field or not related, having enough experience in engineering, and you like to do something short and which gives you, some information about mechanical engineering, you can do a professional certificate because entry requirements are very simple and you can get into the different areas of mechanical engineering, including gas turbines, HVAC, hydraulics, onshore or offshore pipelines. The very good one is the prof cert in mechanical engineering, the first one as well. So that's a 3-month long course. After that, you can also have advanced diploma. So advanced diploma is more rigorous, like it is 18-month long course. It requires you to have some industry background, and then you can pursue this. So we have 2 advanced diplomas, one in mechanical engineering technology and another one is in plant engineering. So that's there. And this one is showing you different modules of advanced diploma of mechanical engineering. So you can see there are 21 modules, but each module is 2 to 4 weeks long. As you can see, some of are little longer, but it gives you comprehensive idea and knowledge and all the industry relevant information of all of these areas or sub-disciplines of mechanical engineering. So it's around 18 months long, and you can see some dates here as well. And let's go to the next one, which is the higher education programs. So higher education programs, you have undergraduate courses. So these two are done online, your undergraduate certificate. But if you want to do full Bachelor of Science in Mechanical Engineering, this one is very good. You can either do it online, fully online, 3 years, or you can come on campus in Australia. So it's 3-year long as well. And if you are looking for a postgraduate or a master's degree, this is our postgraduate areas. So we offer graduate certificate, graduate diploma, or you want to pursue full Master of Engineering, either online or on campus. It's a 2-year long Master of Engineering. It's very, very impactful and it's very industry ready. So you can be industry ready graduate by pursuing either the bachelor's or the master's course with EIT. And I would like to introduce you to Doctor of Engineering. So here you can see EIT offers all the way from short 3-month long professional certificate to all the way to advanced diploma, bachelor's, master's, and Doctor of Engineering as well. And in Doctor of Engineering, especially in mechanical engineering, we are looking for, big pool of researchers and more PhD students, doctorate students. So if you are aiming to have, if you already did your bachelor's with honors with some industry experience, or you did master's, it is a good idea to pursue Doctor of Engineering, which is recognized worldwide. And that's the highest qualification in mechanical engineering if you want to do it. So it's again 3 years full-time or part-time equivalent. You can also do your Doctor of Engineering either fully online or you can come on campus. We have 2 campuses in Australia which offers Doctor of Engineering. So feel free to get in touch with any of these courses. So our campuses, as I said, one is in Perth, then Melbourne and Brisbane. There are 3 campuses, and we actually use local lecturers who are experts in the field. But in combination of that, we also use people who are all over the world, can stream into your classroom if they are experts in USA, Europe, or New Zealand, or wherever they are. If there are any expert in the field, we'll bring you into your classroom, streaming into your classroom, which is really, really amazing. And in terms of our delivery model for our online and on-campus learning, as I said, we have a global pool of lecturers. So it's not always the local person with a degree is teaching you. Usually we actually engage industry people coming into your classroom or experts in the field coming into your classroom or streaming into your classroom across the globe. And you can see we have quite a few students from 160 countries and with lots of online and physical libraries available here. And we also have virtual and remote labs, which I'll be talking about in a moment. So here you can see EIT's lecturers around the globe. So we have lecturers all over the world. You can see this map is showing you we have lecturers coming, streaming in or coming into your classroom from US, Canada, South America, Africa, Europe, Asia, Australia, and New Zealand. So a wide variety of experts we employ to teach you the cutting edge knowledge which is needed in your mechanical engineering course. So in terms of course delivery, we use some advanced software like Moodle, which is in which you would have your subject details and all this information. And we also use Big Blue Button to host the live sessions and the lectures and the tutorials. Now let me talk about labs and industry engagement, because engineering is incomplete without the labs and industry connections, which gives you really practical and industry relevant information. So we actually have remote and virtual labs. So it means that our online and on-campus students can access the labs and the virtual labs from anywhere in the world 24/7. So we have servers in Western Australia, servers in South Africa, United Kingdom, and it's all connected. It means if you have a computer and an internet, and if you are sitting on somewhere, let's say Madagascar or Alaska or Antarctica, we have had students from Antarctica as well. At least one student who was positioned there on Antarctica, he was doing a course with EIT. So these remote and virtual labs, I'm going to talk a little bit more. So let's say we have this hydraulic machine. There is a rig on campus here, and that rig, the people who are studying on campus can actually operate that rig. But for our online students who cannot really come on campus, who are sitting somewhere else in the world and doing this Bachelor of Science or Master of Engineering and Mechanical, they can actually take that lab on their computer. So we have developed some modules in which the module would systematically teach them about how to conduct that experiment on that machine. It would slowly show them all the theory, the video. The videos are also interactive, in which the quizzes would pop up, and it would also actually guide them how to identify different components of the machine, how to connect the components, and how to run this component in a rig in an experiment. So it's a very, very interactive lab and number of labs we are developing. And this is a photo of our production line training system. So this production line is kind of an assembly line. If you have seen a car assembly line, similar to that, this is a small product assembly line module. And if you are on campus, you can operate it from campus, or you can access it remotely as well. So that's the beauty of virtual and remote labs at EIT. And in terms of the software, now students sometimes ask, how can we access different software? Like if we are somewhere else and we are doing the online course with you, because all of this software, let's say AutoCAD or ANSYS or SolidWorks, these are very expensive software. And that's the reason EIT is hosting all of this software in their virtual and remote labs. So all you need is a simple computer or a laptop and an internet connection. You can actually log into our virtual or remote labs and virtual labs remotely, and you can access all of these softwares for free. I mean, free means you don't have to pay extra for it. The course fees include the access to all of this software through virtual labs. So that serves really well with our online students, and obviously on-campus students can also come either do the experiments or virtual labs in classrooms, or they can do it remotely in virtual labs as well. So these are all fabulous mechanical engineering software, which you can see them here. And typically in a classroom, your lecturer, who is actually expert in the field, would teach you how to use certain software live in front of you, and they would guide you step by step how to design something using AutoCAD or SolidWorks, for example, how to do finite element analysis of a particular structure or a machine. And the third one would be computational fluid dynamics. CFD is a very good area. So Fluent is the software. Fluent is the software they use. They would teach you how different systems and the flow of air or liquid is flowing through the system. And you can also, they will also be teaching you aerodynamics of vehicles and spacecraft and airplanes. So all of these is covered in variety of units in your mechanical engineering degree based on what you do. So these are some of the samples. What is happening in the classroom, what is happening in the virtual labs is all right here. I've given you all the samples. It's super exciting. The graduates literally said to me, some recent graduates, that whatever we learned in each and every subject is directly applicable in the industry. And they really enjoy working in the company because they are very confident, they know everything, and all they need to do is just adjust, adapt to the company's system, and they can hit the ground running very quickly. Now you might be wondering how EIT can have connections with industry. Do we do any industrial activity? Yes, we do. So here are a couple of photos from industry site visits and internships which are available in mechanical engineering. So in terms of site visits, here you can see one of the big manufacturing unit, Hoffman Engineering. I regularly take students to the unit. It's a huge facility, having manufacturing, automation, and defense projects, space projects. All of these are going on here. We also take them to water treatment plant, for example, where they learn a lot about mechanical engineering and automation. So these are just a couple of samples showing you strong industry connections mechanical engineering at EIT has with the industry, and you as a student or a graduate would hugely benefit from our courses. So yes, that's all from me. I would like to now hand over back to Tony or Nozibusiso. Thank you.
Hello, everyone. I am Nozibusiso Nkomo. Hey, I would just like to share with you the experience that I had at EIT. I'm not sure if I'm audible.
Yes, we can
Yes,
hear
you
you.
are. We
Okay.
can hear you.
All right. Thank you. Okay. I would just like to share the experience that I had at EIT that also I'm currently having. So I will start with the first one, that why did I choose EIT? So let me just explain to those maybe that they still want to decide if maybe they have to go for EIT or not. So what really stood out for me, their innovative delivery methods and flexible they offer. As someone working full-time, because working full-time is very demanding, so I needed a program that will fit into my schedule. And EIT really delivered exactly that for me, because I didn't have to struggle much because there were a lot of support that I received. So so far, the experience exceeded my expectation, because when I'm looking at that, what I was expecting, I thought maybe I will feel isolated, I will feel left out, but it well balanced with my study and then also with my work. So now I'm currently able to juggle on both. And then the next one, how do you find studying online at EIT with EIT? Studying online with EIT has been truly empowering for me. So the platform is flexible. We've got labs that we have to utilize, as the doctor said currently, to say that they are very expensive labs that are there, and also the resources that we are using, and you utilize those resources for free because it's part of the package that they offer. And those platforms, they help us a lot. So I can learn, which means that I can learn on my own at my own space. I can learn on my own at my own space while meeting the deadlines, because I'm still working as well. So what's even better, it's how interactive the experience is. Thanks to the support of the lecturers that, and the tools provided, and like labs, and it genuinely feels like I'm part of the real classroom, and it helped me a lot with that. And then, have you been able to apply what I've learned? Yes, absolutely, I have. One of the best part of this journey is how practical and learning has been. I'm in the asset management side where I am dealing with work management. So for me, it helped me a lot, because if we are dealing with work management, we are dealing with a lot of technology. So as the doctor said, that it's advancement, especially on the mechanical engineering side, to the and give it that feel of technology. Because remember, right now we are living in the world of technology, and we have to make sure that we move from the manual things and move over to the technology. So currently, what I will say, applying the knowledge at work, it helped me a lot, because this journey have given me a knowledge that has made me a real impact in how I work and solve the problem, especially on the reliability side and also on the work management side. Okay, and then the other one, did I ever feel like maybe if I was feeling nervous when I started? Yes, I will be honest about that. Before starting, I was very nervous about managing my time, because I thought maybe I won't be able to balance between work and also full-time work and also online studies, because you have to be committed for both. So, but EIT structured approach and flexible scheduling helped me find the rhythm that works. Now I feel more confident in both my studies and my job. So it's helping me a lot, because most of the people, they say, how are you doing it? And then I can tell you it is possible. It's just that you have to make sure that you commit, and then you are ready to take your career into the next level, of which it is very important for everyone. Hey, how has EIT uh, helped me to prepare for the workforce in the next career? I would just like to share. It helped me a lot to prepare for my next career. As on the first of September, I started on my new career. I've got a new job, and being at EIT, it have equipped me for my next career move. And I'm so excited about my new role that I'm currently in. The course content is aligned with real industry challenges, and I've gained skills that I use every day. Because here where I am, we use mostly technology. So more important, I've built the confidence to take a new responsibilities and explore new opportunities. I'm no longer afraid to take on new opportunities. I just grab them because I know that I'm ready for that. And then what online tools platform? Okay, the online tools platform and technology, the tools we use in the course have been incredibly helpful. Mostly, is our main learning platform, and we also use simulation software, the labs, to apply theory to practice. This technology makes remote learning feel practical and connected and effective. So which means you don't miss out on anything. What I like mostly with this, it's to do the AutoCAD. I'm enjoying that one very much because it helped me a lot to understand more about the advance in the AutoCAD area. What surprised me most at EIT? What I can share with you, what surprised me most was how engaging the online learning environment. You don't feel like you are there alone, or you feel like maybe you are not part of the class. I expected remote study to feel isolating, but honestly, instead, I find a strong sense of connection with my lecturers, fellow students, because we've got project where we have to do them as students, and then the course content itself, it's very powerful. I try to compare it with other courses. This one, it's very informative. So please don't even doubt maybe or have a second doubt to go for it. And then what advice for future student that maybe they're still thinking that maybe do we have to go for it or not? If you're still thinking about starting your journey with EIT, my advice is simple. Just go for it. Don't let doubts about time management or online learning hold you back. So EIT is designed to support working professional, and the resources are incredible, accessible. Stay committed, ask questions, engage in the class. So if you connect in the class, remember these are the live classes. So you have to engage, you have to ask questions, because the more you ask questions, the more you gain knowledge. So make use of the support that is available there. Like the labs, you have to book them on time so that you will be able to utilize them. So it will be, yeah, very amazing at what you can achieve, really. So just to motivate anyone maybe that is still thinking like, maybe do I have to go for it or not? When I reflect on my journey with AIT, I realize it's more than just a course. It's a transformation. I've grown in knowledge, confidence, capability. To anyone considering this part, don't wait for the perfect moment. Create it. Remember, you are the one who is in control of your own destiny. So create it, uh, and then make sure that you manage your time very well. And then EIT will give you the tools, the support, the flexibility to succeed. Wherever you are working full time or juggling responsibility, I am a mother, I am a wife, I am a leader at work. So I have to juggle different things. So whatever you are doing, maybe you are just chasing your dream. So take the next step. So please enroll and take the next step and invest in yourself, because when you enroll at EIT, you are investing in yourself. Because once you start, you will discover that you are capable of more than you ever imagined. And remember, the future doesn't just happen. It's built by those who dare to learn, grow, and lead. So thank you very much. That's all on my side.
Okay, thank you, Nozibusiso. Thank you very much. And I would like to thank you all for the insightful and informative session for the on the mechanical engineering options available at EIT. Dr. Arti, Dr. Arvin, and Dr. Milind, your presentation provided valuable clarity and depth on the different pathways on opportunity in the field of engineering. And I hope it was appreciated by our attendees for the day. And a special thanks to you as well, Nozibusiso, for sharing your personal experience as a student at EIT. Your perspective added a meaningful and relatable touch to the session. Something exciting for our attendees. We have a competition at EIT, Automate EIT's engineering competition video. Basically, what you need to do is showcase your creativity and humor in a video for a chance to claim the grand prize of 2,000 USD, or be one of the 10 runner-up to pocket 100 USD each. Whether it's a clever twist or a traditional tool or a hilarious automation idea, your 3-minute skit could turn engineering creativity into a cash reward. Yes. Conditions do apply. I will be sharing the links shortly on the chat box for you to join the competition. Okay. So as I've mentioned in the beginning, that I will be sharing the QR code for the certificate of attendance, and I will also be posting the link so that you are able to claim your certificate of attendance. And please do use your real name when claiming the certificate of attendance. Avoid using your nicknames. It seems like we don't have questions from our attendees. Let me just give everyone, all the attendees, 2 minutes to send their questions. And if you can type in your, Edmond, you can type in your question on the chat box, then we'll be able to answer it. I'm just going to give all the attendees 2 minutes. And if we don't have any questions by then we will just wrap the today's session.
Hi, Nyasa. So yeah, thanks for your question. Currently, we don't have tech class structures offered as a part of any of our courses, but we offer AutoCAD, we offer SolidWorks, we offer Autodesk Inventor. So more or less, all of this software are very, very similar. So as a part of the course, if you learned one of these, you should be able to use similar principles in using other softwares from other brands as well. So I hope that helps. And Adu is asking, please, I want to ask if there is a chance of teaching opportunities. Oh, that's an interesting one. So for teaching opportunities, just look at EIT websites. And if you have any CV or if you are interested, just send us an email. Yeah, and we'll look into that.
Thank you very much, Dr. Milind, for answering the questions. I think our attendees don't have. Okay, I'm gonna put it now, Adu, on the screen for you. You can just visit our website for more information. Thank you, Mr. Dr. Milind, for the email. For the website link. So you can check our website. You can book a call also with our course advisors, and you will get assisted. Dr. Milind? You want to add something, Dr. Milind?
No, I'm all good. Yes, thank you, everyone. Thank you, Naisa, Adu, for your questions. Yeah, please get in touch with me or with Tony. There is email address given here, so you can approach with your queries here. So we should be able to help you from there. Thank you.
Okay. Yes, I think we let's wrap up because our attendees don't have more questions, it seems. But yes, on the screen, these are some of the ways to contact us, and I've shared the link for certificate of attendance. The competition also, the link has been shared. Then you can just go on our website if you want more information. We'll be able to assist you further then. Adi Peter, I think I've taken your email address. Let me see. I'll send an email to you separately after the session so that we can assist you further. Okay, there's the email. Thanks once more, Dr. Milind, Dr. Arti, and Dr. Arvin, and our student also Nozibusiso. Thanks, and I hope all the attendees found this session valuable and insightful. And yeah, I think we're gonna call it a day, and I wish everyone a wonderful evening, depending where or morning, depending where you are situated. Any last words from our presenters?
Thank you very much, Tony, and thank you, everyone. Yeah, it was really nice presenting here, and thank you so much for your attendance to this session.
Thank you.
Thank you, Tony.
Oh, perfect. Thank you. You guys have a great day.
Bye, Tony.